So polynomial features, and then, of course, well, anytime we import a class, the next step is to, of course, create an object of this class, and this object will be exactly the tool that will allow us to create this matrix of the features x1, x1 squared, x1 at the power of n. I will precise what n we choose then, we will choose several of them, but there you go, that's what we build with this polynomial features class. And so, well, we're going to call this object of this class poly underscore reg, as polynomial regressor, but it's not exactly the regressor itself because, the final polynomial regressor will be the combination of this matrix of powered features and the linear regressor, and that's why we will call it actually linreg2, you will see. So polyreg will be created as an instance or an object of this polynomial features class. So we're going to paste that here, adding some parentheses, and that is where we're going to choose the n. You know that n here is exactly chosen in this new class. So first we're going to start with 2. Okay, we're going to build a polynomial regression model resulting from the equation y equals b0 plus b1 x1 plus b2 x1 squared, where x1 is of course the position levels and y is the salaries. Alright, so let's create this. Let's precise degree, which is the name of the parameter for that n, equals 2, and then we'll try 3 and 4. Okay, then next step. Well, the next step is now to proceed to this transformation of this simple matrix of features containing only x1, meaning exactly this column. So far, this is our matrix of features of only one feature. And now we're going to transform this matrix of a single feature into this new matrix of features containing x1 as a first feature, x1 squared as a second feature, and then that's it, because so far we started with n equal 2. But if we chose, for example, n equal 3, well, the matrix of features would be x1, x1 squared, and x1 at the power of 3. All right? So that's what we're going to do. And to do this, well, we're going to take, of course, our polyreg object again, from which we're going to call the method fitTransform again. You're starting to know this method. That's, the method that usually proceeds to a transformation. And here, the transformation is to turn this matrix of a single feature into this new matrix of features composed of x1 as the first feature and x1 squared as the second feature. All right? fitTransform, then some parentheses. And then according to you now, what do we have to input here? Well, that's pretty obvious. That's exactly the matrix of features we want to transform into this matrix of squared features, let's say, right? So x of course, that's what we want to transform. X so far is only composed of this column. Okay, so fitTransform x, and now we have our new matrix of features. However, this exactly returns this new matrix of features, so now we're going to create a new variable which will be this new matrix of features itself, and we're going to call it x underscore poly equals what is returned by this fitTransform method applied to x. Great, so now we have exactly the matrix of features composed of the position levels and the squares of the position levels. Good. So now, according to you, what are we going to do? Well, as I said at the beginning, it's like now we have a new matrix of features, composed of these two variables here. And well, very simply, we just have to build a linear regression model that will integrate these features into this equation. Y equals b0 plus b1 x1 plus b2 x1 squared. Right? You see the idea? That's where the linear comes from. And therefore, well, you know what to do. You know how to create such a linear regressor, but we have to create a new one, which is of course different than this one, because this one is already trained on this matrix of single feature x, and therefore having already learned coefficient. So now we need to create a new one, which we're going to call, of course, linreg, and I'm adding underscore 2, which therefore will be a new object of this linear regression class, adding some parentheses. And well, this object will be now trained on this new matrix of features composed of the position levels at different powers, and of course then the salary, because indeed we need the dependent variable vector to train the linear regression model and any machine learning model. Alright, so the next step and final step is to of course call this new linear regressor object that we've just created, from which we're going to call the fit method, which will take as input, of course, this new matrix of features containing the position levels at different powers, and of course the same dependent variable vector, which are the salaries. Alright, so let's do this. Let's input first x poly and then y, and there you go, you have your polynomial regression model. Congratulations! Now you know how to build a nonlinear regression model, and that's what we're going to see clearly with the next steps when visualizing the linear regression results first and the polynomial regression results. Now you know how to build such a model and you have them in the toolkit. So you're getting more power in machine learning, more knowledge, more skills. Congratulations! That's amazing. And now I can't wait to move on to the next tutorial to show you indeed the different results we get with linear regression and polynomial regression. So I'll see you in the next tutorial. Let's quickly run this cell in order to, get the model itself. And now whenever you're ready, let's proceed to the next tutorial for the visualizations. And until then, enjoy machine learning.